Going to be doing anything new. We are just going to go over this and make a nice connection between the unit circle and what we had been doing. So it says, let's make a sketch of a unit circle. We're making a little one. And what makes a circle a unit circle? Yeah, the radius is equal to 1 unit. So that's why I have the points. Now, if I impose the unit circle on a coordinate grid, those are 1, 0, 0, 1. So now what we're going to do is we're going to go through and identify the quadrantal angles. So I would have 0 degrees or 0 radians, 90 degrees. Then what are the radians for 90? Not pi. Pi is 180. Pi over 2. So then I'd have 180 degrees pi. Then this is 270 degrees. Does anybody remember what are the radians? Can you start to remember them? What's radians for 270? 3 pi over 2. A full rotation is 360 degrees and 2 pi. Remember that the x-coordinate is cosine theta. The y-coordinate is sine theta. And tangent was sine theta over cosine theta. And I could draw a point x comma y and redo that, but we've done that before. So those are the things that we're supposed to know. So actually, let me take this and cut it. So every single point is cosine theta comma sine theta. So now, I'm going to do letter A, and then I'm going to pause and let you try B through F. It says, using this sketch above, evaluate without using a calculator. So if I want to find the sine of 90 degrees, I'm going to rotate to 90 degrees, and then I'm going to look at the coordinate points, and what am I going to look at, the x or the y value? The y value. So the sine of 90 degrees is 1. All right, I'm going to give you about 1 minute. Try B through F. Do as many of these as you can. I've started to throw in some reciprocals, cosecant and cotangent. So if 0 is underneath, it's undefined. But 0 on the top is okay. All right, so let's look at cosine 180 degrees. So Gabe, where would you go look? Where would I find that information? I don't want the answer, but where would I find it? Awesome. You rotate to 180 degrees, and then I like how you said that. You're going to look at the x-coordinate. So not a lot of written work, but the mental looking. All right, in letter C, tangent 270 degrees. So Jordan, can you tell me how would I get started on that one? Nice job. Okay, so I'm going to write a little bit something first. I'm going to rotate to 270 degrees first. Okay, rotate to 270 degrees, and then we have to remember that tangent is sine over cosine. And I like how you described that y over the x. Uh-oh, if zero's underneath, it's undefined. Do not ever leave -1 over 0 as an answer. That's not an acceptable answer. If zero's on the top, it's okay, and it's 0. All right, cosine 90 degrees. Zoe, what'd you get for that one? Good job. You rotate to 90, it's the x coordinate. All right, Ellie, what did you do for cosecant 180 degrees? How'd you get started? Okay, great job. So here's kind of the hint to get started. You do need the sine of 180 degrees, and cosecant is the reciprocal, 1 over that. So I go over to 180 and the sign is 0, so I have 1 divided by 0, which is undefined. All right, then Wyatt with letter F, cotangent 90 degrees. What can you tell me to get started with this one?
I started by going to 180 degrees and doing the x and y.
Mm-hmm.
And then I put
So what do you know about cotangent?
that it's sine over cosine.
Well, don't we know tangent is sine over cosine?
Oh, yeah.
Then it's flipped. So then you're going to want cosine 90 degrees over sine 90 degrees. So that's the x over the y. It's okay to have 0 on the top. Okay? All right. Let's look here. If I have I want the tangent of theta, and theta is 45 degrees. I'm going to drop a perpendicular. This is a 45, 45 right triangle. So the tangent of 45 degrees is 1 over 1, or 1. And in a moment, we're going to talk about all the 45-degree angles on the unit circle. And what I want to point out by doing this is they're all going to be some form of, for tangent, it'll be 1. It'll be 1 or -1, depending on what quadrant I'm in. For the tangent of pi over 3 is 60. So this is forming a 30-60. So the tangent of pi over 3 is radical 3 over 1, or radical 3. All right, so now what I want us to do here is I want us to draw a unit circle, but I want us to focus on the pi over 4s. So pi over 4s go like this. They're halfway through each quadrant, and here's the connection, like why we look at the unit circle to help us here. It goes 1, 3, 5, 7, 1, 3, 5, 7, 1, 3, 5, 7. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. All right, what I'd like you to do is I'd like you to echo me 1, 3, 5, 7. Okay, can you do it? 1. What did you say? 1, 3, 5, 7. Can you say that? Ready? 1. All right, let's try this again. Do 1, 3, 5, 7. 1, 3, 5, 7. 1, 3, 5, 7. 1, 3, 5, 7. 1, 3, 5, 7. 1, You've got it. Okay. So the 1, 3, 5, 7s are helping us with the pi over 4s. In degrees, this is 45 degrees, 135 degrees, 225 degrees, 315 degrees. It will make your life substantially easier if you remember these radian and degree numbers. They're not too bad. And so the big idea here, in a 45, 45 right triangle, it goes 1, 1, square root 2. So anytime you see an angle with the pi over 4, assuming it's a reduced, it's not 6 pi over 4, but it's a 1, 3, 5, or 7, what you're going to do is cosine 5 pi over 4, that is the third quadrant. Okay, so I recognize what quadrant I'm in. My reference angle is 45, or pi over 4. All students take calculus. Cosine is 1 over square root 2, and it's negative. And I can tidy that one up. Do you see how quickly I can figure these out doing a combination of what I know about the unit circle and what I know about 45, 45 right triangles? Let me talk you through this one more time. I need to recognize 5 pi over 4 is a pi over 4 reference angle. 5 pi over 4 is third quadrant because it went 1, 3, 5. All students take cosine's negative. Cosine 45 from a 45, 45 right triangle is 1 over square root 2. So this is negative 1 over square root 2, or rationalize. All right, try B and C. See if you can come up with those two. Figure out what quadrant are you in. This is a 45 reference angle. And then you're doing TOA. And is it positive or negative in that quadrant? For letter B, are you getting negative 1? Yes. All right, letter C, 3 pi over 4, wrong quadrant. Second quadrant. Reference angle, pi over 4. All students, sign is positive. It's 1 over square root 2, which is square root 2 over 2. Do you see we're getting faster at it now? A little bit faster. All right, now we're going to focus on pi over 6. So we did quadrantals. If it's quadrantal, 0, 90, 180, 270, 360, it's just the x or y for sine and cosine, or tangent is sine over cosine. If it's 45s, it's 1, 3, 5, 7. I do a 45 and put positive or negatives. Now, we're going to go to the pi over 6s. Well, my pi over 6s, it's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. In degrees, that's 30, 150, 210, 330. Pi over 6, remember, and we echoed this around the room, pi over 6 is 30 degrees. And so I'm 30 degrees away from the x-axis. All right, I'm going to do the first one and then give you about a minute to do the other two. if I want to find the tangent of 5 pi over 6 without a calculator, I know that 5 pi over 6 is the second quadrant. All students take calculus. In the second quadrant, tangent is negative. My reference angle is pi over 6, or 30 degrees. Tangent of 30 is 1 over square root 3. So this is negative square root 3 over 3. You may always make a sketch, determine the reference angle, make your triangle. I'm just trying to show you a way that you can do these a little bit faster if you understand how the unit circle works. All right, try B and C now. All right, this is third quadrant. Sine is negative. My reference angle is the pi over 6, so it's 1 over 2. That's negative 1/2. It's that simple. (11 pi over 6). This is fourth quadrant. Cosine is negative. Or excuse me, cosine is positive. All students take calculus, so cosine is positive. This is radical 3 over 2. Questions? What can I clarify that would help this be easier to understand? All right, then let's do the pi over 3's. So pi over 3 is 60 degrees. So then if I want to be 60 degrees away over here, that's 2 pi over 3, which is 120. Now another pi over 3 is 3 pi over 3, which is pi. Then I'm going to go another pi over 3, which is 4 pi over 3, which is 240. And then I do 5 pi over 3, which is 300. So I'm going to make my 30-60, but rotate it. And you could use the original 30-60 right triangle. So I'm going to do letter A and then give you a brief minute to try B and C ahead of me. So I have the tangent of 5 pi over 3. So that's 300 degrees, so I'm in the fourth quadrant. All students take calculus. This is going to be negative. I'm coming from 60 degrees. That's radical 3 over 1, which is negative radical 3. All right, try B and C. All right, here we go. 2 pi over 3, that's the second quadrant. Sine is positive, that's radical 3 over 2. 4 pi over 3 is third quadrant. Cosine is negative, and that's 1 over 2. All right, questions on that? All right, number 6. Now I've mixed them up. So you use whichever method you're going to use on the next quiz. We're not having one this week, but next week we'll have a quiz next Friday. It says find the exact value of each trigonometric function. So figure out where it is. Is it quadrantal? Quadrantals are just on the unit circle. Otherwise, you need triangles for the other ones.
Can you spell this out?
Sure. For letter A, I figure out my reference angle is pi over 3 or 60 degrees. 4 sets of pi over 3 is 240, so that puts it in the third quadrant. If I'm 60 degrees away, you can draw your triangle, and sine would be negative square root 3 over 2. For letter B, pi is quadrantal. Okay, pi is quadrantal. So I know this is going to be the sine of pi over the cosine of pi. So that's 0 over negative 1, which is 0. Cotangent, 3 pi over 4. I need to remember my 1, 3, 5, 7. So that's 3 pi over 4 is second quadrant. My reference angle is pi over 4 or 45 degrees. And I have all students take calculus. In the second quadrant, that's negative. So it's negative 1.